Hello, everyone. Welcome to this new episode of the season 2 of Swift Academy podcast. Today, I'm very happy to be with Tim Condon, that come from the United Kingdom, from Manchester. And Tim is responsible, the main developers, or one of the main developers in the Vapor project, which is the main project for the Swift backend, if you can say. And also he's the author and the writer of books about vapor. Hello, Tim, and how are you? This is a little presentation, and
Yeah. Hi
yes.
there. It's great to be here. Thank you for having me.
Okay, thank you. Today we'll speak about vapor and also from another topic, which is backup for front BFF, especially for iOS. And there is a lot of confusion about this topic. There is a lot
hmm
of problem between backend and front end about this topic, and we'll discuss this with you. And first of all, it's like state of the situation of the vapor. What is your assessment of the vapor current state in 2025? What is
Yeah.
the yes?
So Vapor's in a pretty good state at the moment. We've managed the transition to Swift Concurrency relatively well.
Okay, great.
So Vapor 4 has been out for nearly 6 years now. So we've had a stable API for 6 years,
Yes,
which has been a challenge at times
yes,
because we can't break our API. But we've managed to adopt Swift Concurrency as additional APIs. And it's in a very healthy place. We've got a great ecosystem, a great community, and we're in the midst of writing Vapor 5 at the moment. So
okay,
that the new version has been underway for a few months now. There's going to be some relatively fundamental changes internally,
okay,
but hopefully externally it should be quite a relatively smooth transition.
okay, great. And I think that you have this improvement using Swift 6 also to
Yep.
integrate some new things about Swift concurrency and also the new things about Swift 6. Can you speak about all this 6 years of handling, managing this great project, especially with a lot of databasing, relation databasing,
hmm
no relation database like Mongo, MySQL, etc., Postgres, and over how the Vapor community involved over these years. There is a lot of contributor. How you can manage this? It's an open source
There is, yeah.
project. There is, and also there is Apple also because you have what we call the Swift server group that you are member of
Yep.
this. The evolution it's of the project over the years. How you can handle things with Apple to integrate this new things. Can you speak about a little bit this?
Yeah, so I mean, there are a lot of moving parts, that's for sure.
Okay.
So I joined the core team in 2020, I think, 2020,
Okay.
2021. I can't remember.
Okay.
So it's important to say that I'm standing on the shoulders of many people who've gone before me, especially Tanner and Logan, who were the original creators of Vapor,
Okay.
and also Gwyn, who's the other core team member who handles a lot of the database stuff. But yeah,
Okay.
you're right. We have a massive community. We have hundreds of contributors to the project, and I spend a lot of my time on GitHub reviewing pull requests and going through code and checking issues and stuff. Yeah, I mean, it's fun. It's working in open source is a very unique environment.
Yes.
We work with people all over the world, and there's not many places where you kind of have that openness and that community. So it's a fun place to be. In terms of managing it, the Vapor core team and Gwyn work well together, and we have lots of discussions around kind of the direction of things and where we should go and stuff. And as you say, I'm part of the Swift server work group, so we also get some both inputs and steering from them and the other way as well to say, these are the focuses of where the ecosystem should be moving, and these are the parts that are missing from the ecosystem that we need. So whether it's adopting Swift Concurrency or working on tooling or stuff like that. So yeah, there's a lot of different pieces to my job. It's never boring, that's for sure.
Okay, great. And for the how to maintain, what kind of things, what is the process that people come, okay, to say, okay, I will be contributor, I have some improvement in the code. What is the process? How you can manage things? Everyone can contribute, or there is some
Yeah.
standards, etc. For
So I mean, anyone is welcome to contribute. We have a full contributing guide on our documentation sites that talks people through how to contribute. And we also have a number of issues, and there's some project boards on GitHub where you can see issues across our different repositories that have been tagged with good first issue if it's your first time. But we take everything from fixing typos in documentation to full new features. But it depends on how much you want to contribute, really. If you're trying to fix a small bug, then you can probably just put up a PR. If you're fixing typos and stuff, then definitely just put up a PR. If you're trying to build something more substantial or add kind of newer features that are more than just a small piece of work, then the best thing to do is discuss that with us on the forums or on Discord or on GitHub first to make sure that it aligns with the direction of the project, because we don't take everything.
Yes.
Anything
Great.
that gets contributed, we effectively commit to maintaining. And there are some things that don't make sense for the wider Vapor project. They might make sense for your project. And we have a healthy community org that has lots of different packages in that don't make sense to be in the main Vapor repo.
Okay, great. Thank you. Maybe that we can go dive to some technical evolution of the Vapor. What, from your point of view, what's the major technical improvement decision? The technical decision. I think that you have some technical decision that really shaped Vapor architecture. That you can, okay, I didn't miss it. It was really a great challenge to decide that we go with the decision, because really a solution like Vapor, it's not easy to make some technical decision. What's the most one decision that with the core team or with other contributor that you have in mind and you say, okay, this was a great decision?
Well, that's a good question. I think there's definitely a lot of decisions that we've made that we look back on and were the right decision and were the wrong decision. I think with Vapor 5, we kind of made a kind of guess on when Swift 6 would land, and we misjudged it. We were wrong, which has kind of left us in a good position where Vapor 4 has been very stable for very long, but we are carrying a lot of tech debt that has meant we can't adopt stuff as easily. So things like structured concurrency, we can't adopt that internally in Vapor because it would require some breaking changes. Or adopting things like actors internally because that breaks your API. But I think the stability we've provided over the last few years, whilst also being able to adopt Swift Concurrency, has been a good decision. And most of the decisions are driven from usage. I work on Vapor and also work with clients who use Vapor. So I get to see a lot of real world experience of people using Vapor. I get to build real projects with Vapor and large applications with Vapor and see where the pain points are. And that drives a lot of decisions of, which things work really well and which things don't work as well, that will help either change the current version of Vapor or inform the next version of Vapor.
Yes, and I think that this transformation to the Swift concurrency is a really great change. And how you can maintain adding new features like this, if you can say features, changes, great changes using actor instead of classes or struct. What is the impact? It's really we cannot until now decide, okay, maybe it's a wrong choice, to choose the actors, etc. Because we break all the API of maybe of the project if we go with using actor, and how you can balance with this kind of new features and the maintainability of the project of the this open source project.
Yeah, so there's definitely a lot to balance. I think in terms of adding Swift concurrency to Vapor, it was a very easy decision. The future-based stuff that we had in the past, whilst it worked extremely well, it was a large barrier to entry of people trying to learn Vapor, because you had all these nested callbacks. You had to learn the difference between a flat map and a flat map throwing and a tri-flat map, and it was very confusing. So the simplification of adding Swift concurrency was huge, and adopting that and maintaining those extra APIs is a no-brainer. It's very easy. I think other changes are more nuanced and interesting. So, for instance, in the new version of JWT-Kit, which is our library for JWTs, that was released a couple of months ago, I think. That's fully Swift concurrency, Swift 6, full sendable. And for that, we use an actor to store our keys, because we needed some we needed a type that could be accessed from different threads that was safe. And we chose an actor. And that was an interesting decision, because we could have gone for something else. We could have used locks and done it manually, or we could have used a mutex. And it's a balancing act, because it means it changes the API for our consumers, and in some aspects makes it a little bit more difficult to use, because any calls now need an await. But then it also makes it much easier for us to maintain, because we don't have to worry about checking locks and making sure nothing gets through that can't get through, in terms of like sendable and stuff. So it's about weighing up those benefits and the risks and the costs and stuff. So in that instance, I think there could have been an argument for using a mutex instead, but I think in terms of simplicity for maintainability, actors are great for us. So it was the right decision.
Okay, I understand. And this come to another question: how you prioritize this kind of decision of coming? Okay, we can go to the migration to Swift concurrency, etc. I think that there is this kind of decision is made by the core team. It is real, or it's how you can if you have like a kind of features around along the 2025 or before that, in you have this kind of organization of feature that you have, or something that come from an idea for someone that came, okay, we can go with this kind of especially because the project it's used by a lot of company and a lot of developers. I don't think that there is no organization, there is no this kind of tickets that are prepared to go, okay, we go with concurrency, we go with using of actors, all this stuff. We will make the change to Swift 6. All this work, I think that's it's organized before by you and all the core team. If it is true or not?
Yes, it is.
Okay.
So I think in terms of how we organize it and stuff, I think we, as a core team, we know kind of the high level goals that we want to hit and the features we want to add. So for Vapor 5, we want to be fully Swift concurrency, structured concurrency, and make it very easy to use. Those goals are easy to define. Working out how we implement those goals generally is a little bit more difficult. So we kind of have an idea, and I think the core team are very active in the community.
Okay.
We have a very, very busy Discord that lots of people talk on and discuss stuff. So we're pretty aware of where the community wants to go and the kind of things that people are looking for. And both me and Gwyn work on Vapor projects full time as well. So we're both developing Vapor and working on Vapor projects. So we're aware of how easy it is to use and where the issues are. So that helps define what we should be working on as well. And then some of it is just pure timing. So for instance, we're very interested in Swift macros.
Okay.
We know macros would be huge especially for Fluent, which is our database layer.
Okay.
But currently we can't use them. They're not suitable for using in libraries. The issues they have with build times and dependency hell, because Swift syntax isn't properly versioned. I think it's kind of tied to the toolchain, but not bundled in the toolchain. Makes it almost impossible to use as a library, especially for something like with Vapor, like Vapor. So it looks like in Swift 6.1, those issues might be solved, which will then allow us to jump on to using macros. So we're very keen to use it, but if we can't, then we won't use them. But we want to. So a lot of it's kind of where the community wants to go, and some of it is pure luck and timing in terms of when things are ready for us to use.
Okay, great. And that's come to another question for me. Compare it to some solution like Spring, like Node.js, etc. They have a lot of mechanism like Spring Boot, Spring Batch, etc. What, if we can say, what is the maturity of Vapor compared to this solution that come since 20 years, since with a lot of API, etc., with a lot of mechanism to data like Spring Boot to take dependency injection, etc., with annotation, a lot of annotation. You have in your roadmap something related to this. We can compare it to solution like Spring Boot, like Node.js, etc.
Yeah, I think certainly at the beginning, the ecosystem was fairly bare for Swift on the server.
Yes.
These days, I think there are pretty much packages for most things. And it's very rare these days where I find I have to write a package for some kind of API or SDK or something like that. It does happen, but it's pretty rare these days. Whereas at the beginning, everything needed an SDK or an API. So I think in terms of like the ecosystem overall, the Swift and Server ecosystem and Vapor ecosystem are pretty mature, and you can do pretty much anything that you need to. I think in terms of comparing it to like Spring or Node.js, yes, they obviously have much more established ecosystems and many, many more packages. But that doesn't necessarily make it a good thing. Like the Node package ecosystem is huge, but there are packages that you can get a package for seeing if a number's even or not.
Yes.
There's not a lot of point in some of those packages. And I think Swift itself has a lot of stuff integrated directly into the language that's you can't find in other ecosystems. So things like Swift Concurrency, even Swift Concurrency. There are other languages and other ecosystems where concurrency isn't built into the language directly. You need to put it in as a package. So I think overall the ecosystem is great. And compared to some of the more traditional ecosystems, things aren't as needed. Like a dependency injection library is an interesting one because we are currently tackling that problem with Vapor 5.
Yes.
Of how do we inject services and stuff into things. And frankly, I think the way things are looking right now, we can just use plain old boring dependency injection through constructors via protocols if needed. We don't need to make it any more complicated. The language makes it easy enough to do and provides us the type safety that we get. And I think that's a huge win. The safety that Swift has on the back end is pretty unique. There aren't many other languages that come close. Rust is probably another one that has similar safety guarantees, especially for the memory efficiency as well. So in Java and Spring Boot, everything you pass around, you have to check for nulls. In Swift, null pointer exceptions don't exist.
Yes.
That used to be, half the code I used to write in Java was checking for nulls. And you just don't have to do that in Swift. So those kind of benefits are huge, I think.
Yes, it's great. Okay, it was the first topic. We were speaking about Vapor, the evolution. Hopefully, we'll have Vapor 5, the integration of Swift concurrency, actor, etc. It's great. I think that the community, especially that I see that a lot of developers come to develop for macOS application. And that's why there is a lot of speaking about using Swift in backend. I think that you have the integration with Docker also, which is really interesting thing for continuous integration. Last time I have to deploy using backend application using AWS, WS, and it was great. It was great to using this fluently and all this stuff, the annotation, everything. I think it's great using support of many database, Postgres, MySQL, this kind of. It's really interesting. I mean, the code it's very simple for developers that come from iOS or simple. It's all Swift.
That is the idea, and especially with Swift concurrency as well. Now it's the same concurrency model, no matter which
the same, yes.
platform you're building for.
Yes. Okay, that we come to speak about the second topic, for me the philosophic topic, the backend for front, which should come with a lot of confusions, a lot of problem between backend and frontend teams. What is the BFF? Something like that. And first of all, we need to understand the concept because there is a lot of confusion. When we read documentations about that, what we call multiple BFF. One BFF to handle every teams. Some cons and pros for that. I need to have this understanding for you about BFF. I know that to come since 5 years in Paris to speak about BFF, and I really appreciate your explanation about that. Maybe after 5 years things change. Our understanding of BFF changes. I don't know. I need your. What do you think about that?
Yeah, so BFFs are an interesting one. The general idea is that most modern backends are built by different teams. Certainly, as you kind of get to larger apps and larger teams, you have a different team that's building your backend.
Yes.
They're also providing an API for many platforms. So mobile apps, TV apps, web apps. And so the API is very generic.
Yes.
And especially on mobile apps, you tend to find that populating screens, especially the home screen on your apps, can be 50, 100 API calls to get all the different pieces of information you need. So the general idea with BFFs is to create an API that your mobile application can hit. And it's not always specifically for mobiles, but it generally is where it's used. So you want to create an API that does all the complex work for you, that provides a very simple API for you to use. So instead of your backend making 100 API calls, you have your BFF that makes all those different API calls and returns only the data that you need. So there's a number of benefits for this. The first one is that your BFF can live in the same data center or server environment that your APIs are. And so the connection is much more reliable, it's much quicker. And so getting all those API requests is much more efficient. And then you only need to return a single response with only the data you want. So you're not downloading loads of extra data that you don't need. So if you have a mobile app that's on a slow internet connection, cellular connection, then it can make one network request instead of 50 network requests where some might fail, and only download the data it needs, whilst the BFF can do all the complicated work. And the BFF can provide an API that works for your mobile application, rather than just a generic API that works for everything. So that's the general idea. they're great because you don't have to go through App Store review. So if you want to tweak some data on that you pull from the backend and format it in a different way, you can just push a change to your BFF, and your mobile apps will get that automatically without having to go through App Store review, which is also helpful. And yeah, so they can make life a lot easier if they're done properly.
Okay, but people, they have a lot of definition. People think about multiple BFF, BFF for iOS, Android, etc., and one BFF that handle, and we have and handle all this, maybe client, if you can say it. And there is, if you go to have a lot of BFF, we can come to with problem of duplication of code, duplication of call of the API. You have maybe two BFF that call the same microservice, if we can say. We have this BFF that speak with microservice that speak with databases, etc. At this moment, we have some kind of duplication of code, duplication of code to the same microservice. And there is a lot of from your point of view, we need to have one BFF, or it depends. We have a lot BFF for Android, iOS, etc.
Yeah, so it depends, but my general rules when working with BFFs are it should be one BFF per application.
Okay.
That's kind of the general rule, one BFF per application. Now, whether the application includes iOS and Android is kind of a team decision, and it depends on how similar your apps are. Because if they're completely identical and they're making the exact same API requests and they're making the exact same, they need the exact same API responses, then you can reuse the same BFF.
Okay.
If there are subtle differences between iOS and Android, say the pages load differently or the UI is different or they're more platform-specific stuff that you need, then that's probably the point where you want separate BFFs. One of the big advantages of a BFF is that it's managed by the mobile team or by the application team, I should say.
Okay.
So it's not managed by the backend team. So one of the big problems that you have with traditional backends, especially in big companies, is that you say, I need a new API that provides me this. You can put it from all these different microservices, and they're like, sure, file a Jira ticket. We'll get to it in a couple of months. So if the backend team is managing your BFF, then changes are gated through that backend team. You're not empowered to make the changes yourself. Whereas if the mobile team owns the BFF, then the mobile team can make the changes as and when they need. Which is why I also think that the BFF should be in the same language that the mobile teams know.
Okay.
So usually Swift for iOS, but it doesn't have to be. But I think if there are barriers to entry to updating the BFF, if it's in a language that no one knows, then that's going to be problematic. Which is why I always try and push to make BFFs in the same language.
Okay. And from your point of view, we have in the mobile teams, a team that handle the development of the BFF and the communication with the backend. It's not the role of...
It should be the same developers. Same developers
the same
building
developer.
The app. Yeah.
Okay.
Because the developers are the ones that know the APIs they need. So just let the developers build their own APIs.
Okay. It's not the role of the backend to understand what the need of the front end. It's the role of the front end teams to understand what their need. And from your point of view, they need some experience, because people that come from the front end that didn't have any experience with how to combine code, etc. There is a problem of performance. Some decision from people that didn't have code from backend. A lot of developers now, iOS didn't code for backend. There is no what we call full stack developers, and at this moment there is a challenge. Some decisions some decisions, and maybe the level of experience of developers with Swift Vapor kind of solution, for example, to create a BFF. I think that there is some challenges about that. Developers come from the platform, they are the same that create the BFF.
Mhm.
I don't know. What do you think about that?
Yeah, there are definitely challenges because it's a new paradigm for developers to learn.
Okay.
I think the idea of using a language that's they already know reduces that massively. So if you're an Android developer, then probably build a Kotlin backend. If you're a Swift developer or iOS developer, build a Swift backend. That makes it much, much easier to get up and running with backend stuff. But yeah, there is a little bit of training required or a little bit of understanding of how backend should work or how to build backend applications or the things you need to worry about. For instance, you might be handling requests from hundreds of thousands of users instead of just one.
Yes.
There are some things you need to think about. But I think overall, if you provide the training or you allow your developers to learn and understand these things, then you're generally the thing we see is that velocity for the backend team, velocity for the mobile teams massively increases when they can control their own backends.
Okay.
Because they're not waiting for another team to fix something that might be way down on that priority list. They're empowered to make the changes that they need and for the stuff that they need for their features.
Okay, but it depends also because they will consume the existing API that exists in the backend and microservice. That may be challenge of performance, because if this kind of API that come from backend is not really optimized, there is we need to make a lot of flat map call for everything, etc. And at this moment, the time to have the response will be increased, because now we have client, BFF, microservice, database, I don't know, maybe passing by what we call the API gateway, something like that. A lot of time that data come, the response come to the client. And if we will add this kind of layer like BFF with non-optimized backend microservice, we'll have a lot of problem because we add a layer that that causes problems.
Potentially, yes. But overall,
Okay.
generally what I've seen when helping teams implement BFFs is that it provides big performance increases. So the times actually reduce. And this is partly because the complex API calls can be done on a single server that's close to the rest of the API. So if you imagine your mobile app has to make, let's say, 10 network requests that go through an API gateway that talk to different microservices. Each one of those requests is going to take half a second, maybe, because you're on a cellular connection. And then you need to parse all that data and then put it into the right format you want, and then display it on the mobile app. What I found is that generally, in my experience, moving a lot of that logic to a BFF reduces those request times down from, say, half a second to 100 milliseconds, even with people who are not used to writing backend applications. Because remember, Swift is actually a very performance-based language.
Yes.
Compared to other languages that are less inclined. And because you're downloading less data, the requests tend to take less anyway. And because the data is already in the format that you need, there's less processing required on the mobile device, so you can display the information straight away, rather than having to wait for all these different network requests to come in, aggregate all that data, transform it. That's already done for you on a much more powerful machine in a data center next to the APIs. And so overall, the time taken to display data on the mobile apps is less than if it was done directly on the mobile apps.
Okay, great. And from your point of view, Vapor architecture, it's suitable for this kind of BFF, to create a BFF. I think that you have a lot of example using BFF, using architecture Vapor. What kind of keys or something that you say, okay, Vapor is really suitable to make this kind of BFF? You can speak about that. Some API that help us to create easily BFF. for Swift applications.
Yeah. So I mean, Vapor is definitely very well suited. It makes it very easy to handle lots of different requests.
Okay.
And we use Async HTTP clients, which is a high performance HTTP client on the back end for making network requests. So it's much more efficient than URL session.
Okay.
It has features like connection pooling and stuff like that. So if you're connecting to the same backends, you don't have to remake those connections. Their connections are already there and open.
Okay.
And you don't have to implement any of that. It's all done for you. Yeah, Vapor has the tools that you need to make network requests to your APIs, add in authentication headers or whatever you need, and then it's just Swift code that you know and can take your data, optimize it, and then return it. So yeah, those kind of things are very easy to build in Vapor.
Okay. And what kind of what we count the common pitfalls to avoid when creating backend using Vapors? Because from your experience, from the real project that you develop using Vapor and BFF, what kind of what we call the pitfalls that to avoid when building this kind of BFF?
Yeah, I think one of the common ones I see, especially with iOS teams building BFFs using Vapor, is
Yes.
don't use singletons. So on iOS, you generally have one user for your entire application. So you can store stuff in singletons or in global variables, and it's fine because you have one user. If you start trying to do that with Vapor, you have potentially thousands of concurrent requests happening at the same time, all of different users. So if you start trying to store stuff in singletons or global variables, then all that data is going to get mixed up. So that's probably the common pitfall, I think. And I think the other things are make sure you use the tools that Vapor provides. So use the network client that we have. Don't use URL session. Take advantage of being able to use Swift encodable types and stuff like that. And you can even share them as well if you want. So you can share your network types. So you don't have to worry about what the stuff going over the network is. It's just codable on both sides. That makes it very powerful. And be careful about evolving your APIs as well.
Yes.
Especially when it comes to Swift, that's very rigid on the things that it needs. And if the fields are missing, then codable decoding fails. But that's probably the big pitfalls to watch out for.
And I think that Vapor, it's also suitable for the kind of what we call pooling real-time application, especially for banking, etc. And if we have this kind of BFF, which we have a lot of, I think it's based on WebSocket. If I'm true about that, and using WebSocket, because I used that using WebSocket, using Vapor, and it was really very, very, very swiftly, very quickly, everything. But okay, it's not real application, it's not banking application, but because there is a lot of challenge about that. And I think it's really what kind of project of maybe you have some names of projects of a company that use now Vapor as a BFF. I think that SoundCloud, something like that. They use Vapor as a BFF.
I think I've heard that. Yeah. I think. What can I share? I can say that there are a number of healthcare companies doing it, financial companies, education companies. So there's many different sectors using Vapor for BFFs. And they work very well.
And there is a documentation about that. People that come to create their BFF using Vapor, they try to have some examples, some advices from the community about that, or
that's a good question, actually. I don't think we have anything specific, but maybe we should build something. Yeah, I mean, because it's not that complicated. You're just making third-party API requests at the end of the day, and then aggregating the data. So But yeah, I think we can probably provide some documentation at some point for that. So there's no reason why not.
Yes, because I think that if people that come to the application team come to create BFF for and to convince especially managers about that, which is not very easily, especially in company, etc., with a lot of investment in this kind of things. First of all, to convince the manager about that, and after that to come to create things, because if you are not comfortable with creating BFF and you are not have some kind of levels, there is a lot of money that will be lost and at this time there is a lot of problem with the management about okay, we choose to have this kind of to create BFF. We know that's good, but the, we have a lot of money and also time, because time it's money.
Yep.
And having this kind of documentation, this kind of resources can help people to understand things before they deep dive to develop things that are not good or not suitable. I don't know. Some choices using BFF, it's not easy to every developers, from my point of view, to do some what we call architecture choices, or need to we need to call this to format to have this kind of response. It may be easy, but when we come to real things, I think that there is a lot of challenges that come with that. And let's come to a little question about your experience about what we call versioning API and versioning API on BFF, and how to handle things with the API that comes from the backend, because we have this kind of mapping. Okay, we have this version of API in the backend and from your side or so, and all this process of releasing, especially we have releasing with the releasing team. How we can versioning things correctly without have no problem, especially in production, using BFF.
Yeah. Good question. So I think one of the important things to note, and one of the big advantages of BFFs, is that you get to control the deployment of it.
Okay.
So if you're using your mobile app to directly talk to APIs, you cannot guarantee easily that every client has updated to the latest version that has the latest version of the API in order for your API to remove things. If you're using a BFF that you can control, then you can make sure that every instance of your BFF is running the latest code using the latest models. So it's actually much easier for API teams to change their APIs if you have BFFs, because it's much easier to make deployment changes. In terms of actually versioning the APIs and stuff like that, it's general best practices. So you make only non-breaking changes to start with. So let's say you are sending data, you can only add new fields, you can't remove them. And so you have to kind of do it in 2 or 3 stages. So you add the new fields, you then make sure everyone's updated, and then you can roll out the updates that removes the old fields. For updating or versioning APIs for your BFF, then that's where you have to be a lot more careful in terms of updating things that the app requires, because as I said, it's much harder to make sure that every instance of the installed app has been updated. So unless you have things like forced updates, you cannot guarantee that they've been updated. And even if you do have forced updates, you still have to wait a couple of weeks for everyone to update and then migrate to the latest version. So generally, you have to try and add or change your API in non-breaking ways, which means lots of optionals for receiving data. So if you're saying adding a new field for data that you're expecting to be sent to you as a BFF, you have to make that optional, and then handle the case where that doesn't exist using defaults or something like that. When you're returning data, you can add much more. You can add extra data because the decoding will just ignore the extra data, but you have to make sure you keep the existing data. So a good example of this is, let's say you have a BFF that returns information about users, and originally you had a name field, and then you want to change that to a first name and a second name field, or first name and surname field.
Okay.
You have to keep the name field for as long as you know that there are clients out there that don't have the updated API
Yes.
specs.
Yes.
And so in this instance, you can either version the API, so you have a version the API, so you have a V1 that returns name, and you have a V2 that returns the
Yes.
first name and surname, or you just return first name, surname, and then name, which is the first name and surname combined.
Okay.
And that makes it possible to do it in non-breaking ways. So you just kind of have to think about it and make sure that it doesn't break and test it. And the great thing about BFF as well, especially if it's written in Swift, is that you can spin it up as part of your integration tests for your mobile app and make sure that your mobile app works against running the latest version of BFF.
Yes. Yes. Great. And what kind of maybe tools to monitor and debugging with BFF? There is maybe in Vapor some tools to do that, to make monitoring, especially, I don't know. I know that there is AWS solution like Cloud Azure, AWS to maintain this, but maybe there is something to tools to debugging when we try to using solution like Vapor as BFF, back for front. What kind of tools to monitor and debugging from?
Yeah. So in the server world, this is all kind of falls under observability. And you have three main pillars of observability. You have logging, metrics, and tracing.
Yes.
Vapor supports all three. And there are API packages that are common across the entire Swift server ecosystem for logging, metrics, and tracing. So we output logs, we output metrics, and you can turn on tracing. So that it makes it easy to track and see what's happening to your requests. And then you just plug in whatever backend you want. So for logging, it depends on how you deploy, but generally just log to the console. For metrics, you can push metrics to Prometheus, and then you can that allows you to set up like Grafana graphs and stuff like that, where you can monitor the number of failed requests and see where things are going wrong and stuff like that. And so those are the kind of tools that you should use to make sure that your APIs are up and running and working correctly.
Okay, let's come to my last question. What is your advices for teams that try to this transition from traditional backend to BFF, especially for developers that come from application, there are front-end application, what kind of devices you can give to them?
Okay, so I think first thing is do some design up front. So make sure you understand the APIs that you need to call, how you need to transform the data, and the data that you want to return to the iOS app. So generally when I'm doing with this teams, what we'll do is we'll go through the iOS app and we go through the different screens, or maybe a subset of the different screens. And for each screen, we'll define the data that we need for that screen. So if it's the home page and you're building like a feed, for instance, we might say, okay, well, we need 50 feed items. The feed items should contain this information, and this is how pagination is going to work. And then from that, you can build your data models. And then the data models can be used to inform what the BFF should return. And then we can work out how to populate all that information. So that's kind of some upfront design. For actually building and developing it, just start building. Vapor is a Swift project built by Swift developers, for Swift developers. It's pretty easy to get going. And so we can, there are some teams where I've built custom templates and stuff for them where that has a lot of kind of stuff integrated already, such as logging and metrics and things like that. But generally just start building a Vapor project and see how it works. And then go from there.
Yes. Thank you, Tim. It was the first episode of this second season. It was great. We have a lot of knowledge about Vapor. I think that with my little experience with Vapor, the using little applications that come to maybe think to create a BFF and for their project, convince management to do that. I think it's a great thing to do, and it's improving in the career of iOS developer to go with this kind of challenges and have the time to learn with your help the community of Vapor developers. That can be great things. I hope that you find this episode great also for you.
Yeah,
Kind
it's been
of
great fun.
question.
Thank you.
Thank you. See you soon and thank you, Tim.
Thanks
Bye.
very much for having me. It's been great fun.
Thank you.